Assalamualaikum and hello everyone. Welcome to our project showcase for CPC357 IoT Architecture and Smart Applications. My name is Ahmad Hazan Shauki and together with my partner Ikmal Aidid, we are presenting the Smart Drainage Pipe Monitoring System. So what is Smart Drainage Monitoring? Essentially, it is an end-to-end IoT ecosystem designed to track infrastructure health in real time. We are transforming urban management from a reactive model to one driven by proactive intelligence. The system is built on three pillars. Real-time intelligence, we replace periodic inspections with continuous 24/7 data streams. Automated monitoring, sensors that detect water levels autonomously without human intervention. Then, early detection. Most importantly, we identify partial blockages before they escalate into dangerous flash floods. Why do we need this? Because the current way we maintain drains has three major limitations. First, it is labor intensive. Maintenance relies on physical site visits. This is slow, expensive, and difficult to scale across a city. Second, it is periodic and inconsistent. Because checks are scheduled, transient blockages or sudden debris build-up are often missed entirely within inspection cycles. Third is the reaction failure mode. Problems are typically identified only after a flood has already occurred. This leads to high repair costs and serious public safety risk. Our solution addresses these issues with a proactive approach. We utilize dual metric sensing, integrating HCSRO for ultrasonic sensor and a YFS401 flow sensor for high confidence detection. We also use Edge Intelligence. The MakerFader S3 processes raw data locally to filter noise and manage alerts instantly. Finally, through cloud synchronization, we deliver data to Firebase for more remote monitoring and historical analytics. Let's look at the architecture we have designed, a four-layer system. The perception layer handles the physical sensing and the local alerts. The network layer manages Wi-Fi transmission. The cloud layer handles storage and synchronization, and the application layer provides the visual interface for the user. Deep diving into the perception layer, we use the HCSR04 for non-contact distance measurement to detect water levels, and the YFS401 to measure flow rate. The MakerFader S3 acts as the central processing unit. Crucially, we have an on-site local alert system. If a blockage is detected, the yellow LED warns of a partial blockage, while the red LED and active buzzer trigger a critical alert. This ensures immediate feedback for crews on the ground. For the network layer, we use the ESP32's integrate Wi-Fi to transmit data via the HTTP REST protocol. We optimize the synchronization interval to just 2 seconds, ensuring near real-time monitoring. This data lands in our cloud layer, powered by Firebase real-time database. We manage two data streams here, a live data stream for instant dashboard updates and historical logging for long-term and trend analysis. Finally, the application layer. This is our web-based dashboard. It provides operational awareness by fetching data every 2 seconds. The interface clearly displays the system status, normal state for clearflow, partial blockage for early sediment detection, and critical alert when immediate intervention is required. Now let's look at our demonstration video.
Okay, now we will demo our smart drainage pipe monitoring system. So over here we have our fader maker microcontroller and all of the wiring. If we go over here is the submersible water pump, which will then pump water through the tube into our bottle, which will act as the pipe in our system. And if you look over here is our ultrasonic sensor, which will measure the distance to the water through the ultrasonic waves and detect any cloggage. And then here's our water flow sensor, which will measure the flow rate of the water going in and out of it. And then we have our red and yellow LED alongside our active buzzer module, which will give immediate local alerts under the right circumstances. And then if you look over here, our serial monitor on Arduino, we have our readings. The data will be sent via Wi-Fi to Firebase, which will then be visualized on our web dashboard live. So let's talk about the actual demonstration. We have defined three status: normal flow, partial blockage, and critical blockage. So let's start with the normal flow by pumping in the water first. So let's look at the water going into the pipe. And then as the water is going to the pipe, let's look at our serial monitor for the readings. As you can see, the distance will slowly become smaller and smaller. And then you can see our web dashboard. The data will be visualized alongside the visual analytics. And that's for normal flow. Next, we will do the partial blockage scenario. This time we have inserted a sponge into the pipe, which will act as a blockage and prevent water from seeping through to the water flow sensor, and also cause the water to accumulate on this side of the pipe. So as we turn on the water pump again, we can look at the reading and see that the distance of the water pipe will slowly decrease. And as it reaches below 6 centimeter, you can look at the buzzer, which will make an occasional beeping sound once in a while, and the yellow LED has turned on. Then we can look at our readings on our web dashboard and see that it has been updated. And look at the analytics too. And that's it. Finally, and most importantly, the critical blockage scenario. This time, we have inserted a solid object into the pipe, which will prevent most, if not all, of the water from flowing through to the water flow and will cause all of the water to accumulate on this side of the pipe. If we turn on the water pump, we let the water go in and we can wait until the water accumulate past a certain distance, which is 4 centimeter. Now it has reached the partial blockage stage. And we can look at the readings now. It is almost below 4 centimeter. And it has reached 4 centimeter and is classified as critical blockage. If you look at our sensors here, you can see the red buzzer has turned on and the active buzzer module is now making a beeping noise constantly. And we can look at our web dashboard and it has updated showing critical blockage. Then we can view the analytics here showing that yes, and all the readings are here. You can look at the graph. And that is all from us. Thank you.
This project isn't just about technology. It aligns directly with UN SDG 11 Sustainable Cities and Communities, specifically Target 11.5. By enabling early detection, we reduce disaster risks and economic losses. This technology provides the backbone needed to build resilient urban environments, enhancing public safety for vulnerable communities. To summarize, we have achieved a complete IoT ecosystem integrating hardware, cloud, and web visualization seamlessly. With robust detection logic via edge processing and real-time intelligence, our system offers a scalable solution for smart cities. We are optimizing maintenance costs and, most importantly, enhancing public safety through early warning. That concludes our presentation on the Smart Drainage Pipe Monitoring System. Thank you for watching.